Hello, my name is Roman. I'm the only thing that separates you from lunch today. But today I'm gonna tell you a case story about how we made from building a RAG system from prototype to a production. And if you're attending multiple buzzwords in a row, you might notice an interesting pattern. So at some year X, the vendor is saying that some technology, it happened with learned RAG, it happened with semantic search or with RAG. They say that it's the best technology in the world. In the next couple of years, practitioners are happening that telling that these actual claims are over-optimistic, and hopefully my talk is like this. So there are some nuances of building RAG system. A couple of words about myself. I'm coming originally from academia, applying machine learning to different areas, mostly e-commerce search. Currently, I'm working at Delivery Hero on food search and food delivery, and I'm also maintaining a couple of open source projects. One of them is MetaRank, like old school learn to rank personalization for your search, like it's 2019. And the second one is a search engine. Like, yes, I'm building a search engine by myself, and this whole story is about my friends using this for a specific case and how it went well or not very well. Nixie Search is like a Lucene search engine on top of S3. It does everything you expect from, Lucene search engine, so it can do all these facets, filters, autocomplete, whatever, like all this all big guys doing. But as a machine learning person by myself, it's also has all this commoditized machine learning things you do with search, like embedding inference, semantic search, cross-encoders for ranking, and also a RAG. And when we implemented this RAG thing, in a couple of months after that, I got an interesting discussion on Slack. So if you have your open source project and it's not like an open source project because your investors say so, but because it's open source by heart, it might start living a specific life without you. So it might get some questions like, okay, that's a nice project, and we're using it in a bank for a RAG or for a code you written 2 weeks ago. And you're like, that's nice, but okay, and we got some issues. And I'm like, I'm not surprised, but anyway, can you help? You're always interested that what can unfold, how this discussion can be unfolded. And the whole story is like a practical use case of how you come into a non-technical organization and try to make it work in the way it was intended by the talks of vendors, like how you can do a RAG in 10 minutes. So the business use case of this problem is to build a support agent for support agents. If you're building a customer-facing business, you have an application, and your actual customers might have problems with this application, so they start speaking with your support agents. So that was the origin of the story. We'll speak about how to get your data into the search engine, about chunking, context length, all the different approaches, and we'll speak about R and G in RAG, so about retrieval and generation. And also complain a lot about this different frameworks you can use to evaluate your RAG. Okay, so the use case, building support agent for support agents. The main problem is that if you ever worked as a support agent, and actually when in my youth I actually worked as a support agent, the 80% of the questions, you get them every day, and you don't even need to go for a knowledge base to get the answer because you remember it because you get it every day for half a year. So you can immediately answer. Some of them you just copy-paste from the knowledge base because they're maybe typical, but you don't remember exact wording by heart. And some of the questions are actual problems you need to focus solving, and you need to have time for solving these problems, but you don't have time because you're busy answering this type of questions. So that was the actual problem. And the idea was not to replace support agents with the ChatGPT, because no one likes chatting with ChatGPT, but more like helping them to offload them for simple tasks so they have time to work on the complex ones. So, and it also helps with onboarding people, because usually there is quite some churn in the support agent team bases, so it's easier than you have some sort of an neural body helping you with some documents you might need to check to get more comfortable with the most typical questions. Okay, so apart from minor difference that we're not using, so the support agent is not going to write a query for your search engine, but because they don't have time to do this. But what you do have, if you have a chat or dialogue happening in an application or within a messenger or like happening by phone. And you can use an LLM to summarize this dialogue into the actual problem and the actual question. And this question can be used as an input for your RAG. And then it's just a classical RAG. You retrieve documents, you summarize the answer, and the support agent can either use this answer as is, or just rephrase it somehow, or just not use it and not accepting it. But reality strikes that usually in the practice there comes some sort of a constraints. If you are operating in a fintech industry and it was a fintech company, you shouldn't really, there are some regulations. So due to regulations, you can't just dump all the financial data for your customers into ChatGPT. Even if the regulations allow you to do it, you shouldn't do this anyway. So this thing should be running locally on premises. The second thing is that this company is operating in a couple of countries with the languages which are not really widely used in an LM community. It's like Uzbek and Kazakh. So you might guess which countries are there. When you start speaking, okay, what software you use for knowledge base, so we'll just quickly just index it into the database, and you like knowledge base, you know? But technically it's still a RAG system. So building a RAG system, every search engine has a tutorial about RAG system. Here is one from Nixie Search, from other search engines. And you know, like building RAG system in 2025 takes around 40 seconds. I measured, so it's a Claude code, build a RAG system. I cut the thinking, so it's like 20 seconds, but actually it's 40. And at the end, it just dumps you a working code. I tried, it's actually working. There are some nuances. So formally it takes around 40 seconds to build a RAG system. But the thing is that that's mostly what we did. Not like just using this code we built for 40 seconds, but at the end it's a very convenient and typical way of building RAG. You convert everything to Markdown, what you have, all the documents. You use some library to do chunking, embed with some embedding, whatever, and use some LLM to do summarize. And a couple of years ago, on a Haystack, there was an interesting metric for evaluating search measured, like it's a CTO at position K, so how many bad results your CTO finds. And we actually used this metric to evaluate our first iteration because we were like very constrained by time and things we couldn't do. And formally, the system worked. So it works, but there are plenty of issues. So there are issues with retrieval. So some important docs are missing in the search results. Irrelevant results are actually found. And from the generation perspective, you might see that wrong summary might be there, or like the wrong question or the wrong answer being generated. So a lot of issues. And if you are trying to evaluate a system, like, you know, from system perspective, you just decompose it, then evaluate, improve, and hope that the systematic experience is also gonna improve. From my personal experience, this RAG consists of three things, like preprocessing, retrieval, and generation. And there are different approaches to approach this type of systematic improvement. You start with like a ground truth data set, or implementing the best new thing, or just trying multiple random things until it works. Usually on conferences, people say that we started from the bottom and moved to the second part. We started from the beginning, because usually if you have like a rapid pace of iterations, it might get better results at the beginning, especially if you're constrained with time. So we started with just checking what frameworks are there for evaluating RAG systems. There is a RAGAS framework. It was already mentioned a couple of times on this conference. And it also goes into the approach that we should separate system into parts, evaluate separately, and then do something with this input. The first problem we got is that about corpus preprocessing. So yes, as usual in large non-technical companies, the knowledge base actually formally exists and spread across the whole organization in different like some managers' notebooks, some sticky notes on a fridge in the kitchen, and so on. Messages forwarded in WhatsApp. You know that seriously we got like one intro message for support agents. It was just a message in WhatsApp. And it's all in 3 languages at once. So, and it's usually what happens with the documentation. It's all stale at the moment of writing and not used. So, but we started to do like a traditional approach to it, like, okay, let's collect everything and translate everything to Markdown, because it's a very simple format. There are plenty of different tools to do this, and the most interesting learning out of that was to use LLM-based transformation tools. So if you have a very complex document, we had no complex documents, but if you do, actually dumping everything to a vision model and just asking it to output Markdown works very well, especially for hard cases. It might cost you money, but for us, it was just a couple of thousands of documents, so it was not really expensive. The second part, okay, you converted somehow your documents into a text format, and now you need to do chunking. As you know, there are like hundreds of different methods of doing chunking, and it's hard to evaluate them, because usually you evaluate some sort of a downstream task, like search and retrieval, but as your data set is like moving and it's not stable, you can't really compare metrics because it's different data sets formally. So what we did is that usually just used our system for, retrieval, and just with a couple of queries, we diagnosed that there are typical cases when chunking is not working correctly, and focused on like typical problems we just eyeballed in the search results. And there are two approaches to do chunking, like large chunking. You just almost not chunk at all, just dump everything and hope that your search engine will handle it somehow and your smart LLM also handle it. And a small, like you just split into a very small chunk, like sentences, and hope that LLM will be smart enough to figure out what you meant. There are problems in these approaches. The first approach is that your chunks might be too big. Maybe for LLM, okay, LLMs have some like a huge context, like 1 million tokens, but still if you drop a book there, it doesn't mean that it's going to be cheap and fast just to summarize and find the answer out of this book. And the second problem, you have a human in the loop. So if you have a question and like, okay, the answer is made in this tutorial for using an application which is 200 pages long, and you're like, nice, I have only 10 seconds to find an answer there. So you're still a human in the loop, and the context length of humans is still very short. Mine is like very narrow. So you should be very careful with chunking. But to fit like a narrow context length of a human, you can go just with a very small chunking, like a sentence-based chunking, but it can be like, you can lose a context due to over chunking. Like in this example, you have a title that it's a trading update for this company, and that's the revenue growth here. Sorry, too big spit. And if you split it by chunks, by sentences, one chunk references another chunk. If it's retrieved in like separately, you have never know which actual company revenue grew, like Acme or something else. There was an interesting publication from Anthropic about using contextual chunking. So the idea was to prepend some context information into each chunk, so it's not gonna be lost. But as LLM providers, they suggested to run LLM to produce context for each chunk, just multiplying your costs like 10 times or 20 times. I'm gonna do the same if I was owning Anthropic. But actually, the idea that if your data set already has some sort of a context, and what we actually had, if we converted everything into Markdown, after eyeballing the search results and the source documents, we see that our titles are actually quite long. Not like a Wikipedia titles, like personal life, of whom I don't know. But we had like an examples, like how can I use a system with my card? This type of title. And this is actually a good context of the whole paragraph downstream. So you can just split it in the way that you have a title from the Markdown as a context, prepend it, and like a paragraph of text to fit the context length of the embedding model. So it's like I call it GPU poor contextual chunking if you have no time and GPUs. At the end, there are plenty of different frameworks to do chunking. I know that Chonky even has a SaaS version, so it's like a hosted regex, so that's a very nice thing. So at the end, we decided just to go with the right approach, because it's like you still split by paragraphs, you need titles. Detecting this with Python is much easier than hitting a SaaS endpoint. So that's what we actually used. And at the end, we just dumped everything to a block storage. As knowledge base is not really frequently updated, it will just immutable index. So you just dump everything into S3, periodically once a day reindex every 3, just dump index on S3, and you got like your immutable index, immutable searcher, so nothing to break, even if something breaks, you just restart thing and just self-heals because there is no state inside, unlike big search engines which are behaving like databases. Then the actual evaluation, and you go to the RAGAS system and start eyeballing the metrics. And these metrics look very smart, but if you look for them for long enough, you might notice that, it's precision, recall, relevancy, yet another relevancy. It looks like all search metrics, so it's always nice to see how people rediscover search metrics again and again, but through the prism of using LLMs. The goal of you as a retrieval part of a RAG system is to make the context the most relevant context you can achieve. So context window is limited. Yes, it can be like a lengthy one, but it's still limited, and you need to fit it with the relevant chunks. So when you do, to evaluate RAG, you actually start building the retrieval part. We haven't yet built it. And as we're using a very specific set of languages, it's also a question which model to choose, because not all models are the same if you are not an English speaker. So we don't have baseline queries, unusual languages, no like public evaluation corpus in this language. How can you choose an embedding model? Just go to an MTB leaderboard and pick the first one. That's what you usually do. But there is a miracle dataset. It's not having any splits for these two languages, but at the end, it's a very nice dataset. And what if we machine translate that? The thing is that the idea of using machine translation datasets for informational retrieval came from Emma Marco. So it's a MS Marco dataset translated with Google Translate and a large set of languages. I always was wondering where did they get so much money to go through the Google Translate. I I sent a message to authors on LinkedIn and say that, okay, our university got a grant which was expired from Google, which got expired, and it was 5 million credits, and we decided to burn them beautifully. So that's how this data set was built, but still Google Translate is very expensive if you're going to translate a very big data set, and other machine translations models were not very nicely performing. So we did our own evaluation of different, and it's 2025, maybe LLMs are translating better than Google Translate, or we can have self-host and so on. So these are all the LLMs we tried. It's an XCOMET metric on a Flores dataset, which is a reference dataset for machine translation models, and for English to a downstream language direction. And so we found out that actually Google Translate is quite nicely working on high resource languages, but if you go for low resource languages, ChatGPT goes in front of Google with quite a huge margins, 87 to 91. It's a big gap in the translation quality. So we decided just to go, we also tried LLMs, so we can run locally. It's almost cheap, it's almost free, but still it was fine to go with LLMs for this route. So we translated the splits into Uzbek and Kazakh and ran a couple of embedding model benchmarks with MTB. You took a custom data set, there was a talk about, it's very easy to do. And we're also originally focusing on multilingual E5 large models of different flavors and focusing on an NDCG at 10, so you can have a lengthy context. And also tried BGE flavors of model like M3 model, and there's also a very not having much of an attention model. It's kind of an old model with a Gamma 2 trained on the BGE dataset. So it's a huge model. But as it's trained, it's an LLM and not an embedding model. It's usually quite a good quality on the downstream tasks on low resource languages. So the question was, is it gonna worth it to use it? And you can see that it just crashed everything on these two languages. So going from E5 large to Gamma, it's from 85 to 89 on NDCG. And it's across both languages, 86 to 89. And yes, it's a huge model, so you can only run it on a GPU, but luckily we can run models on GPU, but it's still a matter of price. So, and even a light quantization is not that affecting retrieval quality. So yes, it's going down, but insignificantly. If you go from int 8, it's going to be just around 10 gigs of VRAM. So it's affordable to use some sort of cheap. If you got on a cloud, it's a cheap instance, but we're running on-prem, something a reasonably not expensive, unlike H100. Yeah, but it's an embedding model. Not a traditional embedding model. It's an LLM, so it's a very specially handcrafted generative model used as an embedding model. And surprisingly, it worked quite well if you just reuse ONNX translation from Sentence Transformer. I also tried doing it with the last week release of Qwen 3, and it actually works almost. So raw export without optimization, no issues. This one is broken, but you don't really need it. It's an optional thing. And for int quantization, it also works quite well, both for Qwen 3. We never tried Qwen 3 there. That's just my personal experiments, but it works both for Qwen 3 and with this Gemma 2. And then plugging it in Nixie Search, I was expecting that I need to struggle a lot to make this work, but surprisingly, that's all I did. So it's just a file plugged as a part of an inference, as a custom embedding model, referenced as a model for the field called content, and that's actually it. The only thing it's like uses a very specific way of pooling, so it's not pooling across all the tokens, but only on the last token. But this is also some embedding models already doing, so it's not like requiring extra implementation there. Okay, so we got our retrieval ready. So now we need to do some sort of evaluation of the retrieval. So if we had labelers or if we had queries, we can just, sit and label this data set. But in reality, usually we don't have both. So RAGAS suggests to use LLM as a judge because it's maybe not as good as human judges, but it's much better than absolutely nothing. So we went with this approach. So the idea of using context precision and recall through an LLM judge, if you have only a context, because we only have documents we have never yet done into production yet, we're just building a prototype system. So we generated like a couple of hundreds of queries for specific parts of the context for the snippets, and then rerun it as a retrieval. You search for this, you know which context is relevant, and you use LLM as a judge, for example, as an OpenAI, to mark this as relevant or irrelevant. You need to be very careful about your definition of relevancy because as you might be subjective on what's relevant, what's not. OpenAI and ChatGPT can also be very subjective. But at the end, we're not going to do in DCG because for the downstream LLM, it doesn't really matter on what position your relevant document is. As far as it's in the context, because it has, not unlike us humans, we're liking the top documents more than the bottom documents. So, and our context length is always usually the same, so you can compute an context precision, context recall with these labels, and go for it as an original metric for context relevancy. There is also another approach of measuring context relevancy, but without LLM as a judge, because you already have an embedding, you have a fixed length context window, like top 10 documents, top 20 documents, and it's usually, unlike e-commerce or some other type of lexical search where the length of your search results is different, you might get it static. So okay, whatever, we return always 10 documents. So you can compute an average cosine distance across all the documents in a fixed length context. So the idea that the higher the cosine distance, the more overall relevant documents are in the context. If you don't have any duplicates there, so you need to be very careful, because if it's the same document copied 10 times, it's going to be very high cosine distance, very nice cosine distance, but not much value for the downstream task. And to some sort of an overview of all the metrics we can use is that absolute numbers usually don't matter much because it's just, okay, in DCG 0.6, so what? But if you make this evaluation as a tight loop, so you quickly iterate, change a different embedding model, change different parameters of your search system, and you see that, okay, your metrics overall, maybe these metrics are noisy, but they're overall improving. That's a nice direction. So you're moving in the right direction. So it's about relative performance with fast automatic evals and not just a single giant number you got, like NDCG of 0.7. Okay, the next part, the G in the RAG. We got our retrieval system somehow working for these languages, but what LLM you should use? Because apart from using kind of a set of obscure languages for search and for generation, you need to have some sort of a balance of how good your LLM is. So you, of course, can take DeepSeek. It's going to be very precise, but you need a giant cluster to run it, and it's going to cost you a ton of money, and it's going to be very slow. So you need to find something in the middle that works reasonably good, and it's okay to run locally. To evaluate generation, there are like two parts of the generation you can evaluate. So it's not just purely generation. It's first like comprehension. So how good your model is understanding what you're actually trying to ask it to do. And the second one is how smooth you can generate, how grammatically correct you're generating the answer. For the comprehension benchmarks, we found quite a nice benchmark from Facebook. It's called Belebele, and they're using it for evaluating Llama. Gemma is using it somewhere, and Google using it to evaluate Gemma models. And at the end, it's just a snippet from a Wikipedia with 4 questions to it, and with 1 question and 4 answers, and just 1 answer is correct. So it's the traditional natural language understanding tasks for LLM. But it is not a machine, but human translated to 100 languages. And this splits for Uzbek and Kazakh are there, so which is very nice. And it's around 300 tasks per language. So it looks like this. So just some sort of a snippet from a Wikipedia and a query, like a question for that, and only a single correct answer. And we run different models. So we got 2 different baselines here. The first one is like a Mistral, just to see how English model can go bad. So like our bottom estimation of an LLM performance on comprehension, and the ChatGPT as a top level of comprehension, and everything else is in between. So there are different models here, a couple of fine-tunes for specific languages, and we see that still Gemma 2, even without fine-tuning for exact language, is still performing quite nice from the perspective of natural language understanding in this case, which looks like our use case. And in a specific language, you can see it like a breakdown per language here. The second part is that you need not only understand what you are trying to say, but also to measure how smooth you can generate the outcome, the answer. Usually you use humans to judge this type of generations. We don't have any humans to do it apart from me, but there is an interesting metric called perplexity. So as you're predicting next token every time, you can see how sure your model about the next token. And if you see the high level of confusion, it means that the model is confused either by language or by the previous context. So it haven't never seen anything like this before. That's why it can't say what should be next. This perplexity metric is kind of a inverse of cross-entropy loss, so it's a little bit complicated, but at the end it depends on the corpus. So these 3 columns are just Wikipedia, and these 2 are our custom corpus, and you can see that Gemma still performs quite well compared to other models. Not the best one. The lower perplexity is better. So not the best one, but we chose Gemma 2 and then later upgraded to Gemma 3 to have some sort of a balance between the performance, ability to comprehend things, and ability to generate consistent language at the end if it was asked to. There is also quite a big uncharted territory we haven't made. So there are 2 metrics which we maybe ever do an answer accuracy. So it's comparing a ground truth prediction, ground truth answer and the prediction, if you have ground truth answers. So but we don't have any ground truth answers, so it's kind of hard to evaluate. So it's a thing for future. And the second part, which is not requiring any reference metric, so it's answer groundness. So it's how your answer is based on your context. So you also use LLM and a judge, but ask it are you actually using the information from the context for this answer, or you just made it out of your metal head. If you watch for how these metrics are actually implemented in RAGAS, so it's a very nice Python API for answer accuracy and response groundness, but if you go into the implementation of these metrics, you might notice that it's nothing all but just LLM prompts. So it's more like, okay, it's a measure how well a response is supported and grounded. And you will see like exactly the sentence and the implementation, like just measure how a response is supported and grounded by this list of documents. So it means that you're not really limited into this set of metrics. So if you have something coming from your stakeholder with this vision of how quality should be defined, you can just copy-paste this phrase as a metric and be very careful how you define the quality of like how you judge the results. So like relying on implicit judgments of OpenAI might be not a very good idea, but what RAGAS support suggests, and I also support, is that you need to have some sort of a rubric classifier about the relevancy of the query, for example. You don't ask like, is it relevant or not? Because understanding what's relevant or not might be dependent on the person, project, whatever, and use case, but you can say, okay, something is relevant only when it's in the same topic and answers exactly on the question from the query, and it's mostly about this question and not with some extra information. That's a relevant document. Like a semi-relevant, you can go for Amazon grades like apps like exact match, substitute, complementary, relevant, or invent your own grade, but still, if you're doing this type of grading, it works much better. In my current company, we also iterated a lot with these prompts for LLM judges, and now our prompt to judge relevancy is like 16 pages long on Google Docs. So eventually you might get very detailed measurements. From the implementation perspective, it was all quite simple. So it was originally one GPU, it went to 2 GPUs in a 4U server, and with 2 models running side by side, both of them Gamma. Now the Gamma 2, 27 billion replaced with the Gamma 3, but at the end it's not that much of a difference. So it's still Llama CPP, and for LLM inference, so in an extra runtime for embedding inference, and overall it's around 100 tokens per second. So not super fast, but as you stream LLM responses directly into the UI through like WebSockets, it doesn't look very slow. So you see your answer, and answers are usually short, so you can like generate 10 token answers per second, which is more than enough for the capacity for this hardware. And it also takes around 500 milliseconds per time to first token. So you have quite a lengthy prompt. This prompt needs to be processed. The main context is like prompt is lengthy, not just because you put 16 pages of guidance there, but also a context of the documents retrieved. So it takes some time, but usually it parallelizes very well. So if you have like a beefy GPU, it works quite fast. And we can technically go for bigger models, but we have never measured, so it's hard to say and how good they are on support of these lower source languages. So the main things we learned, so not yet. So the whole implementation of the system is like this. So it's always nice that you need to run a lot of code to make this system work. So it's just an inference of 2 different models, actually a bit more complicated how to split them between GPUs, and a single field with the content, actually with a language and ID, but like the main one is a content field with just a single semantic model. And that's it. The main things we learned in this whole story is that if you're building system to working with an English language, you're the most happy person in the world, because if you go for lower source languages, it's like going back in time like 3 years ago, but knowing that they're going to be a much smarter model in the future, but you cannot use it. So usually if you're evaluating a very complex system, you just decompose it and have some, instead of one big problem, you have many small problems. It might be easier to judge, but still what we found useful is that sticking into the most complex system is not maybe worth it. You should start simple. And if you have, so LLM as a judge, I'm very skeptical about this approach, but if you have nothing at all, it might be better than nothing. If you have human labelers to re-evaluate your results, of course you should go for humans, because we're all humans. We should get together. And yes, and that's the whole story. So these are my LinkedIn. This is a link for the slides and links for the data set and systems I've used. And trust me, these are not rickrolls. That's it. 35 minutes.
Okay, awesome. Thank you so much. Questions? Yes.
Thank you so much. I was curious about the generation prompts because your application is in tailored for Uzbek and Kazakh conversations. Are they in English or were they in those languages?
The data set itself in these languages, what we found also useful that you can go for tasks in the downstream languages or you can give it in English. Surprisingly, on our metrics, it works better when you give instructions in English. It was also like an eye-opening thing for me, but I guess it's due to the fact that the majority of the training data for LLMs to follow the instructions is made in English, so they're much better understanding instructions in English than in other languages. So if you have a choice, stick to English. So it's all English apart from the context, and it's also at the end, please generate the response in this language. Also written in English, but like, please speak Kazakh.
Gotcha, thank you.
Okay, I have a question from the audience at home. How did you decide on making Markdown as a format to extract the data?
Just it's the simplest one. Like there was a slide about that, with the boys and girls. I don't know, somewhere here, but just like the simplest solution ever. Like what you can use for translation, probably text files, but then you lose a little bit of formatting. If you want persist a little bit of formatting, okay, that's Markdown. Yes, you can go for JSON, but at the end, from the chunking perspective, you still need some sort of a structure, but like on a level of a header and some payload for the text. So Markdown, JSON, CSV, whatever, at the end it ends up dumped into a search engine and you lose this format at all.
Okay. Questions? I have another one from home, but anyone here wants to ask? Yeah, Nick.
When you were giving the context as the Markdown, you said you found giving the header 2 quite effective. I think you did the double hash for H2. Yeah. Did you try giving heading 1 and 2 and 3, or was it just 2 because that's all you had?
That's all we have. So there is no opportunity to give a second level of headers if you don't have second level of titles. So we had only a single level. And it's also, as you do LLM-based conversions, you can also ask it to flatten the structure if you want. So LLM also gives you an ability to control the way you convert. It looks like magic, but for simple documents, it works quite reliably. Even for very complex downstream languages, because you enforce it not to change the text, just only text, take formatting and just copy it directly. And if you don't ask it to rewrite the content, it's still working quite good, even if the downstream language is like not well supported.
Okay. We have another question from the audience. Tom, awesome talk, I agree. Since your data set is quite specific, did you consider fine-tuning your own evaluating model for LLM as a judge?
If we had labels, absolutely we will fine-tune. That's the case. So, but we don't have labels for fine-tuning, generating synthetic labels, and then fine-tuning a model on top of that. I tried, not for this project, but in general, but I haven't found that a strong improvement because you need to be very careful with label generation. And usually you don't have time to write a 16 pages long description on what is actually relevant, because there is a lot of nuances in different cases. So like this 16 pages long guidance for LLM as a judge was made because, there are so many nuances and relevancy of food. I will never believe until I see this document, but it's all like relevant.
Cool. And last question. Yeah.
So you're using like your own self-hosted service. Like, did you compare how would it compare like against for all APIs, for example, like if you will be using something managed? Because you still have to pay for these GPUs, right?
Yes, but it's regulations. So like we can compare, but we cannot use them.
All right, got it.
Okay, so for, I think, sorry, we're out of time, but Roman will be here. You can ask him later. For the folks at home that asked, there are other questions in the chat, so please write them in the chat and Roman can log in later and answer you. And lastly, a big round of applause. Thank you so much, Roman, for this talk. Awesome talk.